Using Excel to determine the linear correlation coefficient and regression equation. This video uses example 1 from section 10-2 and example 1 from section 10-3. The following procedure requires that you have paired sample data in two different lists. In this example, we use the paired data from table 10-1 titled Shoe Print Lengths and Heights of Males. The data for shoe print lengths are entered into column A in Excel, and the data for heights are entered into column B. You can determine the linear correlation coefficient and regression equation using Excel itself or the XLStat add-in. The XLStat add-in is recommended because it lets you use one simple procedure to get the values for both the linear correlation coefficient and regression equation. Excel itself requires two different procedures for the linear correlation coefficient and the regression equation. We begin with the procedure for XLStat, followed by the two procedures using Excel itself. For XLStat, begin by clicking on the XLStat tab in the ribbon. Click on the Modeling Data button and then select Linear Regression from the drop-down menu. You should now see the Linear Regression dialog box. First, enter the range of sample values for the dependent Y variable in the Y dependent variables box. In this example, heights is a dependent variable, so we enter cells B1 through B6. Next, enter the range of quantitative values for the independent X variable in the X explanatory variables box. Also ensure that the quantitative box is checked. In this example, shoe print lengths is the independent variable, so we enter cells A1 through A6. If a variable label is included in the data range, check the Variable Labels box. This example includes variable labels, so we check this box. Select Sheet to display the results on a new worksheet, or select Range and specify a cell if you want the results to be displayed on the current worksheet. Click the Outputs tab. Ensure that the boxes for Correlations and Analysis of Variance are both checked. Click OK to display the results. The results include the linear correlation coefficient, which can be found in the correlation matrix as shown. In this example, the linear correlation coefficient is 0.591. The p-value can be found lower down in the results in the Analysis of Variance section under PR greater than F. In this example, the p-value is 0.294. Because this p-value is not less than or equal to the significance level of 0.05, we conclude that there is not sufficient evidence to support the conclusion that there is a linear correlation between shoe print lengths and heights of people. At the bottom of the results, we find the equation of the regression line. In this example, predicted height equals 125.40733 plus 1.72745 times shoe print length. We can also use Excel itself for finding the linear correlation coefficient. First, click on the Insert Function button on the toolbar. In the Insert Function dialog box, select the category Statistical. In the Select a Function box, scroll down and click on Correl and then click OK. You should now see the Function Arguments dialog box. For Array 1, enter the data range for the independent X variable. In this example, we enter A1 through A6 for shoe print length. In Array 2, enter the data range for the dependent Y variable. In this example, we enter B1 through B6 for height. Click OK and the linear correlation coefficient will be provided. We can also use Excel itself to determine the equation of the regression line. Note that this function is not available in Excel for Mac 2011. Click on the Data tab, then select Data Analysis in the ribbon. If data analysis is not available, you must install the Analysis Tool Pack as described in Section 1.5 of Elementary Statistics Using Excel, 5th edition. You should now see the Data Analysis dialog box. Click on Regression and then click OK. You should now see the Regression dialog box. For input y range, enter the data range for the dependent y variable. In this example, we enter B1 through B6 for height. Next, click on the Input X range box and enter the data range for the independent x variable. In this example, we enter A1 through A6 for shoe print length. Check the Labels box if the first cell in your data includes a data name rather than a data value. In this example, we check this box. Select New Worksheet Ply to display the descriptive statistics on a new worksheet. In the Residuals section, check the box labeled Line Fit Plots. Click OK to display the results. The y-intercept and slope of the regression equation can be found under Coefficients. In this example, predicted height equals 125.40733 plus 1.72745 times shoe print length.